So we'll have 4 tech companies specialized in forestry. So we have Good Forest. Okay, yes, come with me. We have Space Bell 2. We have, we can applaud them, of course. Zaitra and Sylvia Care. So we're going to start then with Good Forest. And a mic.
This one?
Yeah.
Okay.
Floor is
Perfect.
yours.
Thank you. Perfect. Hello, good morning. My name is François, and I am co-founder of Good Forest. Today, I will show you how we are using satellite and AI in order to support forest managers and forest owners. So, due to climate change, as you know, forests are facing increasing risk. Pests, diseases, windthrow, fire. In France alone, tree mortality has more than doubled in just 10 years, and carbon sequestration has been cut in half. The forest you can see in the picture is the Argonne forest. It's a French forest where hundreds of hectares of spruce has been destroyed in just a few months by bark beetles. This has huge impact on forestry management because field surveillance can't keep up with the speed and the scale of this risk. And there is a financial impact for the forest owners due to timber devaluation and tree losses. That's why we created Good Forest. Our ambition is to offer a complete platform managing these multiple risks, so pests, diseases, fire, and storm. We believe that satellite and AI are tomorrow's solution in order to monitor forest in real time and on a large scale. We are developing 3 core capabilities. The first one, monitoring, in order to detect dieback and forest changes in near real time. Then analysis in order to evaluate and to analyze the risk for today and in the long term. And finally, management in order to support forest managers in decision making. We are convinced that forest management will be more and more about risk. And that's why we want to build a complete platform managing this multiple risk. So how does it work? Our solution is like an automatic scanner that monitor forest anywhere at any time. The process is simple. Continuous monitoring thanks to satellite data. Then data enrichment from multiple data sources. Real-time analysis with AI models, so deep learning and machine learning models. And finally, a web application and a mobile application for the users with the alerts and the analysis. We are working with forest managers from cooperative, from management firms. We are working with forest owners, with forest asset managers. And today, between 50,000 and 20,000 hectares across France and Europe are being monitored by our solution. And we have a co-development approach. It means that we are building the solution with these partners in order to fit their needs. So I can show you our different solutions. The first one is the health monitoring for spruce forest. So we monitor forest in near real time, and when we detect dieback, we send an alert to the forest manager. It helps him to know where he needs to go, to target priority plots. So you can see an example. Where it is? Yes. You can see an example of a forest we are monitoring. So it's a bit small, but it's the dieback evolution. The pixels, it's dieback due to bark beetles. And so this is the forest we are monitoring. And the forest manager, so we monitor for this forest manager more than 2,000 hectares. So it's not only this forest, we monitor a lot of forest for this forest manager. And this forest manager uses this application every week in order to know where he needs to go. So it helps him target priority areas. And the benefits are time saved, early detection of bark beetles, and reduction of losses for the forest owner. So this is the first service, health monitoring for spruce. Then we have another service, which is the post-fire damage assessment. So the idea, as it was said before, is to, just a few days after the fire, to be able to map the damage and to quantify the damage. So you can see an analysis we did for a fire in July in France. It's a severity map, and we also did the quantification damage. And the value is that just a few days after the fire, you have rapid information. So rapid information for the forest manager, for the forest owner, for the insurance company, and reliable analysis without waiting weeks after the fire. Our technological approach is a predictive machine learning model based on Sentinel-2. The predictive part is interesting because it allows us to compensate for the satellite delays, revisit delays. We are working on another service which is still in development, which is the post-rinse-through damage assessment. You can see an example of what we did with an insurance company. At the top, it's a field expert assessment. At the bottom, it's our analysis. It was a storm from July as well in France. It's still in development because we need to be more precise in order to meet insurance companies' needs. But there is a clear potential because the value is the same. It's rapid information for the forest owner, the forest manager, the insurance company, and reliable analysis without waiting weeks or waiting months after the storm. The technological approach is a bit different. It's a combination of Sentinel-1 radar and Sentinel-2 multispectral data with deep learning models. It's not machine learning models, deep learning models. And finally, we are developing new use cases with VHR, so very high resolution imagery. There is a lot of use cases, for example, the wind-through damage in order to be more precise, or the identification of individual trees. So you can see an example of an individual dead tree detection. So the red dots are dead trees. It could be useful for a thinning operation, or in order to know what's need to be cut, or for a financial expertise, for example. So this approach, VHR, is complementary with our Sentinel-based monitoring, because Sentinel-based monitoring is more for continuous monitoring in near real time, and VHR will be useful for punctual analysis. So that's it. Thank you, and if you want to know more about our multi-risk management platform, don't hesitate. We will be happy to have a chat about it. Thank you.
Thank you, Benoit. François, sorry, because now I want to welcome on stage Benoit and Remy from SpaceBell, and I think the solution of Good Forest is also super interesting regarding SWIFTT, and maybe we can also enjoy lunchtime to discuss all together the differences. So now it's SpaceBell time, please. You need another mic, yeah.
Good morning, everyone.
Here is the clicker in the center.
So we are from SpaceBell company, which is located in Liège and Oulart, but also in Toulouse in France. We are operating in the upstream sector as an IT software engineering company, but also in the downstream sector. And I'm the responsible of the department dealing with AI and Earth observation applications. So, as the focus of today is more about forestry, I will mostly speak about all the solutions we have been developing in this matter, but we also have applications related to agriculture, disaster management, which is actually also including wildfire hazard prediction, as we have a project which just launched last week. And we are also part of a consortium dealing with resilient mining, using Earth observation data to monitor the pollution related to the mine industry, as well as the ground surface deformation. So at Spacebell, we are using multi-scale approaches according to what we can find as satellite data, airborne data, or drone data in the field we are investigating. And we are closely collaborating with experts in order to integrate their knowledge and field data to improve our models. So we provide easy access and appropriation of Earth observation data, enabling the production of services over large areas in the most automated way possible. We allow for a dynamic approach over time and the visualization of changes, and we ensure ease of visualization of the products related to the forestry product, more specifically, through the integration of thematic platforms or business-oriented platform according to the user needs. And we are developing AI-powered services which are optimized and with cost effectiveness, which are less flexible. But we also have core services that we will show you today, which are more flexible and adapted to customization according to the end user inputs. So first we will dedicate to AI-powered forestry services for the detection and characterization at the tree level into the forest. What we propose is detecting trees and counting trees in a very efficient way to provide a mapping of the species that are present in the forest, and integrate also the canopy height and canopy health monitoring. We mostly focus on European countries, which are orthophotos and high-resolution DEMS digital elevation models available. And we focus on several principal species related to conifers that we can find in our forest, but also deciduous trees, as it's mentioned here. Now Benoit will explain us the workflow that is leading us to this integrated solution.
Thanks, Romy. So here you can see the outline of the workflow. So the core of the workflow is the two deep learning model that we developed. So the first one is one object detection model based on a faster RCNN. And the second one is CNN to classify tree species. So to train this model, we built a training dataset, so extensive dataset, using historical Walloon region orthophoto. So here we select several years to capture as much as we could the variability of the phenomenon. So once the model are trained, then we can build the services. So TeamTrack or another customer can provide us the parcels, and then we are using this parcel, the algorithms are using this parcel to retrieve the orthophotos and the overlapping images, then clip them, mosaic them, and then send it to the models to detect the tree and classify the species. Then the outputs can be integrated in, for example, in TeamTrack WebGIS platform, or to send to a customer. So we tested several standard EO approaches, but the complexity of the canopy make that it didn't perform well. So we moved to a deep learning approach. But as we speak this morning, deep learning needs data. And so it's a big investment in the beginning. So we really need to focus and to prioritize. So we collaborate with TeamTrack to, for example, select the 3 species that are relevant for Forester, and to make sure that the products that we develop are matching the customer needs. And so the other thing that we need scalability. So the goal here is to apply the model on large areas. So we need something that is lightweight. So the model that we choose is faster SCNN. So that offer a good trade-off between performance, accuracy, and speed performance. So here you can see some results of the tree detection and the species classification. Here is the health monitoring that we did at tree level. So you can see in red some trees that are highlighted and unhealthy. So we can provide as well some statistics at parcel level, such as tree count, tree density, tree crown diameters, tree species distribution, and so on. A deep learning model provides some confidence scores, so that's really useful for the user, that they can highlight some, for example, some parcel that perform a bit less well, like in this example in yellow. So alongside this product, we develop as well some pipeline to create automatic reports. And this is interactive map, so you can enable some layer just to see the results. Here's the statistics, the same thing for the species with some pie charts. And here the health monitoring with some statistics and charts. So this was for the standard low-cost products, but we can offer as well some more customized services. Here is an example. So it's a solution based on drone imagery. Sorry, it's in French, but basically it's the same strategy, the same approach. So 2 deep learning models, one faster CNN and one CNN to classify the species. The difference here that we use digital elevation models to improve the model. And we can use as well this DSM and DTM to build a new product, which is the Canopy 8 model. So here you can see the Canopy 8 model, the tree crown detection, and the tree species classification. And some zoom on one specific area.
I will continue with the characterization and monitoring at canopy level. So as we have also strong partnership with the Walloon region in Belgium, we have in the frame of an ESA project, we have developed another technology which is based on a seasonal harmonic model for including tree vegetation indices in order to detect the disease or the outbreaks that we can observe in some forests. And thanks to input data that enable us to validate the observation, we are providing timely plot and maps in order to monitor over time the changes that we can observe in the different forests. This is an example of a forest which was monitored, and on this figure we can see the start of the outbreak. I don't know if there is a pointer, maybe not. And then over time, so it evolves, of course. And we see in 2025 that the forest is actually recovering on its own. And this is an important point that the Wallon region and the foresters managing that forest didn't really notice being in the field. But satellite data was able to tell us that actually this forest was not completely unhealthy, but it regrow and get back to the previous stage. So this is the type of anomaly maps that we provide, always including Z-score in order to measure if this anomaly is clearly or not visible. And this is provided here. We see every 3 years, but of course we can also deliver on a near real-time manner each time we have a Sentinel image arriving. So this is the end of the presentation, and if you want to have more information related to the products we are developing, also related to forestry, don't hesitate to take a look on our website or contact us. We will be responding you with pleasure.
Thank you so much. So now we have online, I believe, Miroslav from Zytra, who will also present their solution. No, not online at all, here with us. Sorry about that. So here, please, can you keep 10 minutes max?
Yeah, I will.
And here you can click here to move on with the slides.
Okay, perfect.
Your time.
Okay, so good morning, everyone. And first of all, I would like to thank the organizers for having opportunity to speak about our solutions. I am Miroslav Rozložník from Zytra, but for a follow-up discussion, if you just call me Miro, I am fine, because I understand it's very, very challenging Slavic name. Our company is based in Brno, which is the second largest city in Czech Republic, and we deal with edge computing, and I don't have my slide. Here we go. Okay, so during my presentation, I will explain you what satellite intelligence and edge computing means from our point of view, and also I will describe you our solution and our approach, how we address time-sensitive scenarios. Nowadays, there are like 1,500 satellites orbiting Earth and providing satellite images. Unfortunately, only a fraction of these images reach the end user because there are several bottlenecks, several constraints, like, for example, data link or quality of the image. And of course, what we already have heard today, that you need high-quality data in timely manner. And this basically creates a conflict because there are some data available which cannot reach you. And to address it, it means that you need to shift some processing capabilities from ground, from Earth, towards to space, because it can help you, especially in these very time-sensitive scenarios. So edge computing means that some of the capabilities which you do with the processing of your images on ground, you move it to satellite, and you do processes, pre-processing, and then the download the data. Once you move this processing to orbit, it opens you new capabilities. You can even create like early warning system, because the processing of the imaging on orbit can help you to understand what is there, and you can get the information very, very, very fast. Of course, edge computing is very challenging, because for those of you who already discussed about this ground-based processing capabilities or based on Sentinel images, you know how powerful computers you need to have to be able to analyze these images. And of course, when we are talking about space assets, in space, you have some constraints. You have constraints of power, because of course the satellites doesn't have 220 to plug in. And of course also processing performance is sort of limited compared to ground computers. And I'm quite proud to say that we have succeeded, and we have created our solution, which is called SkySense system, and basically which is capable to do image processing in orbit. So how our system works Our system is based on 3 base components, which are modular, which means that they work when they are all together because they are optimized, but they can be also separated on different space infrastructures. So first of them is called Skysen system, Skysen Edge, which is AI software deployed on board of the satellite. It can be our satellite, it can be any satellite which is capable to run this software. Then there is a data processing unit, which is basically a space computer, if I can say so. And then we have a ground segment, which is called a Skysen Ground, which is basically a platform which integrates the data. Our system has been partially space qualified. Some of our components already flow in space, but in general, our technology readiness level is at 6, so we are just before deployment and testing real use cases. Our system is very capable because, as you can see in the bottom part of my images, we can detect the area of interest. So as you already described, you have a special part of the forest you are interested. Our solution can basically automatically detect this area of interest directly in orbit. We can detect objects there. We can do categorization of the objects. And most importantly, we can create alerts. So how these alerts work, you can see on this picture, which is basically a schematical view of the functionality. You see the image which is captured by an optical sensor. Then our Skysen system is able to remove clouds, which of course when it's cloudy area, it's no information for you. And then in the area where you have your interest, it detects, in this case, objects. We see here it's the ships, but it can be any variety of objects or events. And once our system detects objects or situation of your interest, we move it forward and we create an alert, which is basically a text message, which can reach you in, let's say, 10 minutes from the detection. Which means that we are not transferring the whole image, but we are transferring information what our AI system sees in the image. And this is something for very, very time-sensitive scenarios and for early warning. Of course, then we can supply this capability either to governments, to institutions, or directly to platforms like it has been shown earlier today. The use cases we are currently supporting are various. As I already said, it's object detection. It can be ships, it can be aircrafts, whatever. But we also can detect, depending on the sensor, of course, we can also detect methane leaks. We can also detect floods and assess damages, and also wildfires. So these are, let's say, sort of plugins which are already implemented in Skysen system, and we are exploring future opportunities. And actually, later this year, we are going to launch our first space node, which will provide satellite intelligence. And the reason why I'm here is to explore with you how we can use this capability for our use. We have no experience with this forestry, and we will be happy to help you to understand what you need and to support your specific use case. The service, since it will be demonstration, it will be free. So basically, it can be even crazy ideas you want to test, but let's test it together. Thank you.
Thank you so much. And for people online, if you have some questions from some of our pitch presenter, please ask them, and we will share the answers. So now we have online. Franck Gauthier from Sylvacare,
Yes,
and it's going to be our last pitch session before the last session. Franck, floor is yours. And if you need to change the slides, please just tell me, and I will do it for you.
Okay, thank you so much. So I will try to be quick because I know it's the break now. I'm Franck Gauthier from Sylvacare company. As you can see, we are a small French company located in the center of France. And our purpose is to work on very early fire detection, mostly for forest, for natural areas. This is our focus. And as we will see later, we are also trying to work on the detection of abnormal heat increasement before flame and smoke appears, but we will see that later. So please, next.
Sorry.
Yes. So as we know, the global warming generates many wildfires and with very negative impacts. And the key points to try to reduce these impacts is to improve the response time. The response time is the time between the time where the fire ignites and the time when the firefighters are able to arrive. So next, please. What is strange is that for years, despite many technological improvements, most of the devices have been based on smoke detection. As you can see on the picture, you can have people on eye spots trying to look at smokes away in order to detect the location of a fire. But these solutions are the source of many false alarms. Next, please. Next slide. Yes, thank you. We also have more and more solutions based on IoT devices located in the forest, in the canopy, and also aerial systems. But most of them are also based on smoke detection. Next, please. And the next one, and the next one. Yes, thank you. But before, yes. The issue is that smoke detection is not very efficient because you have many false alarms and it needs time to detect a fire because you have to wait a big smoke cloud. So at Sylvia Care, we have decided to take this problem in a different way. And our goal is to protect the forest, not by looking above the canopy, but looking under the canopy and to try to detect fire ignition very quickly by using the infrared rays. Next, please. So this is what we can see on this picture. We want, with our device, perform three things. First, reduce the time of detection. This is the key point. The second point is to provide a very precise geolocation because it's usually the firefighters spend a lot of time to try to determine precisely where they have to go. It seems to be strange, but it's the truth. And the next step is to provide images so that the firefighters are able to see what is happening on field. Is it a real fire or is it something else? So this is what we want to do and what we do with our solution. Next, please. So our solution is based on small sensors. These sensors are located in the trees, 3 meters high, under the canopy. And these sensors are fitted with small infrared cameras. And these cameras are always permanently looking around them and trying to catch any abnormal heat increase in order to send an alarm each time this event happens. Next slide, please. So this is a global view of our system. You can have the sensors in the forest. We are also using a communication network that is operated by national operators. This is not our communication network. And we're able to send alarms, pictures to monitoring platforms. And on this slide, we have an example of a platform that we have developed with TeamTrack during a new European project. Next slide, please. Here are some pictures to explain more in details how our devices are working. if you are looking at the bottom of the slides, you can see three images, three couple of images. On the left side, you have what our eyes can see, and on the right side, the black and white images are what our sensors are able to see. And the white dots, the white pixels, are the pixels corresponding to high intensity infrared rays. And these rays are generated either by the fire itself, but also by the mass of air above the fire. And this is all these elements that we are able to detect at distances up to 200 meters. You can see that we can detect at up to 300 meters, but we believe that 200 meters will be large enough. Next step, please. Next slide. So this is the view of one of our sensors. This is our prototype. A new version is now currently in the manufacturing process. It has been installed in a forest. Next slide, please. And here you have a view of our monitoring platform. So it's a usual monitoring platform. You can see where are the sensors, where are they looking, are they in a good operation mode or not, so we can monitor them at a distance. In the middle, you can see infrared images captured by the sensors, because it's possible at any time to get an image from field. It's not necessary to wait for an alarm. And we are also able to get information such as temperature and humidity and other kind of parameters. Next slide, please. So this is another view of another platform. This is the TeamTrack platform, because we have been able to demonstrate that our sensors are easily it's easy to interface them with any kind of platform, and this has been the start of our cooperation with TeamTrack company. Next, please. This is another view of our platform on a smartphone, because the access can be also done on a small smartphone. So you can have all the same informations that you have on the platform. Next one, please. So this is just to remind the key point of our solution. As our solution is based on small sensors, it's very easy to install. It takes few minutes to install the sensor in the forest. It's very easy to set up the parameters. So it's very it's not with respect to big installations such as iSpot. It's very efficient as an installation process. Our sensors are, of course, autonomous, and they provide very fast detection, of course, thanks to the infrared detection. We can also transmit information like images, and this is what I have said. And we are currently at the step where we are starting our first experiments in France to detect fire. And as I previously said, our next step this year is to detect very small temperature changes, not only in forest, but also in the wood transformation business, as an example, in order to detect possible cause of fire. So I thank you very much, and don't hesitate to send me questions, because I will not be there with you today, but don't hesitate. It will be my pleasure to answer to you.
Thank you very much, Frank. And I think it's super interesting to see the sensors also application, different type of tools.